All right. Welcome back, you guys, to our AP Calculus AB review. What I want to do today is go over how we're going to do these problems. I do also have the equations and everything set up on the calculator. You should be using a TI 84, maybe 83. They all do about the same things, but being able to plug these into your calculator to find your answer quickly and swiftly. We are going to go through the 2025 free response questions. We're going to go through number one just real quick. If you do understand as well, we have about 30 minutes for two problems. I'm going to show you how we can get through this in just under 10 minutes. So that's going to be our time limit for this. All right. Very quickly, we get in here, we're going to have to make sure that we identify what they're asking for right away. So first off, invasive species of plant appears in a fruit grove at time equals 0, begins to spread. The function c, all right, they already gave us our first function. This is the algebraic model, algebraic function that they've given us. This is the original equation. This is the uh, number of plants, all right? Models number of acres in the fruit grove, so acres of these plants affected by the species T weeks after the species appears. It can be shown, and here is our derivative function. C prime of t is equal to this function. All right, first problem A. Find the average number of acres affected by the invasive species from time 0 to time t equals 4 weeks. Show the setup for your calculations. Now, whenever they say this, okay, show the setup for your calculations. Okay, show the setup for your calculations. You have to make sure that you show exactly what you're putting into your calculator or what you're going to be solving for in terms of your equation. Okay, so now we have time 0 to 4 weeks. We already understand that's basically our B minus A. Okay, we have our uh, A is equal to 0, B is equal to 4. So that's going to be our 4 minus 0 at the bottom. Okay. Now on the top, we have to understand a big mistake that people use is they start to use the derivative function for this. But right now we're finding area under the curve for C of t. So on the top part of this function, we're going from 0 to 4 of C of t. And don't forget this dt. All right. Remember, if you forget this dt right here, that's actually the point off. You're not going to get your full points if that does not end up in your equation. So keep that in mind. So here, very quickly, we're going to go in here, find our integral. Uh, and one thing that you could do for this, all right, if you go take a look here, I plugged it in here. We can use our calculator for this, right? We have our function right here. Plug that right into our calculator. Now, for those of you that are new or, unfamiliar with how to use this type of calculator, under this math function right here, you can go down here and you see n deriv and n integral. So we can put number 8, which is going to be derivative if you, or 9, which is our integral. So here we have our integral. We're going to be plugging in 0 to 4, 0 to 4. Plug in our 7.6. Let me double check real quick. 7.6 arctan. Arctan is actually our inverse tan. Okay. 0.2 t. So we'll put 0.2. And in this situation, we're going to use x as long as you make sure that you use that x again for your dx here, right? That should give me my answer. 11.1128. Usually in these situations, you should be able to give at least 3 decimal points if you are using your calculator. So making sure, and I'm actually gonna pull up as well so you guys can see here. This is actually the scoring notes. So if you go under your free response questions, you have scoring guidelines. This will actually help you understand what exactly they want to see here. So here again, 1 over 4 minus 0, that's what we start with. 0 to 4, c of t dt, right? Making sure that dt is here, that's a point for your average value formula. Then solving for that, okay, so we just found this so far, making sure that we go into our equation and divide that by 4. So you can see in my calculator as well, this is our original equation. That's our answer. We divide that by 4. So you could just take this and say answer divided by 4. And that's how we get 2.778 as our answer here. Let me switch back over. And you can see 2.778. You just need to be able to show that. And also do your best to make sure that you reply and put your answer in terms of the number or the label that they're looking for. Okay, let's go into B. Find the time t when the instantaneous rate of change c, okay, so that's already asking you for your derivative, equals the average rate of change of c over the time interval of this. So basically, instantaneous rate of change over this average rate of change, you're looking at mean value theorem here, okay? Now in that situation, that's where we're going to be taking this function to find the integral of, and we're going to set up that function, okay? So integral of, there we go. The integral of that, which we also understand we do have this original equation. So now what we can do is we can actually set this up as c of 4 minus c of 0 over 4 minus 0, okay? Uh, because again, it's from A to B, and we basically have c of B minus c of A over B minus A, okay? That's our setup. We can go ahead and plug that into our calculator. So you can see I put in our 7.6 arctan 0.2 times the 4 minus this. If I had gone all the way over, you'll see minus the 1 with 0 in it. That gives us 5.128. Divide that answer by 4, and that's a 1.282. All right, very quick with these ones. Just to show you the answer here. That's our average rate of change answer. Okay. Now, that's 1 point. Okay. That's my setup for this calculation. We can also in here this set up our derivative function to solve for that as well. In this situation, we would just go in and set up our equation where this equals this, multiply this over, and we solve for our t. Okay, so instantaneous rate of change c equals the average rate of change c over the interval of that at this time. Okay, back to our problem. Assume that the invasive species continues to spread according to the given model for all times t is greater than 0. Write a limit expression that describes the end behavior of the rate of change in the number of acres affected by the species. Evaluate this limit expression. Oh, did I not share the right one? Here we go. Okay. That is C. All right. So we're going to write the limit, okay, end behavior of the rate of change in the number of acres affected by this species. So we're going to take the limit as in here t approaches infinity because we're asking for time to approach infinity. All right. As our c prime of t, okay, is equal to, and here we understand it's our limit t approaching infinity of that 38 over 25 plus t squared. So that's our first part. We got a point for this one. All right. If we do evaluate that, basically this t ends up being a very, very large value at the bottom, which eventually approaches zero, right? Anytime your denominator grows extremely large, that is where we will end up having basically a 1 over infinity or any number over infinity in this situation. Quick peek over at the scoring guideline just to show you that's what is expected. We get a point here for writing out that equation. That's the limit expression, and we get it equal to zero, which is our value, and therefore um, that it is. So keep in mind, they also tell you in here what they will not accept. If you forget that limit function and just set the algebra of it equal to zero, that does not count either. We also do not want to take the original function. We want the rate of change to be the one equaling to to zero, right? All right, back into our last part of this. Okay. We're right around 10 minutes, but of course I've been switching back and forth, which also leads into some extra time. Last but not least, at time equals 4 weeks after an invasive species appears in the fruit grove, measures are taken to counter the spread of the species. The function A, defined by this, is modeling the number of acres affected by the species over the time interval from 4 to 36. At what time does A attain its maximum value? Okay, that's where we need to understand. Your mind needs to jump right away to the fact that you have your original function that they just gave you. Your derivative function needs to equal zero to assume a critical value. Okay, critical point, critical value for the original function. Okay, so we need to set this function up equaling a. So a prime of t. So c prime of t. Okay, if I find the derivative of this, it's going to be sorry, it should be minus still 0.1 ln of t dt. Okay, so this function needs to equal zero. All right. Now, here's a part that I think, you know, you could and here use your calculator to solve for this. My favorite way to do that is actually to plug that into our graphing function here. So what I've done here is I've plugged in, obviously here I'm using x's instead, but using our c prime of t, which is 38 over 25 plus x squared, because we can't, or I'm not using t here, plus x squared. And then we are taking this part of the function with a t with the x in there as well. When I go and I set my window, I like to set my window from 0 to the range that they want, 36, okay? Or technically it could be from 4, but I would just use 0. And we can go ahead and graph that function. On here, we can trace this function, and actually, if you go under calculation, so second, the calc function above that trace, you can find the zero by going to the left. So if I'm watching this y value right here, if I go to the left, I need that to be right now above zero. Okay, that's the first one. And then my right bound underneath zero, hit enter, and then allow me to guess. So that finds 11.441 as my answer for where this attains a maximum value. Now, here's the thing. Where does it attain the maximum value? That's the first part of this. We need to answer that, which we just did, 11.441. Now we have to justify that answer. Okay. Now, how do we justify that? We usually want to go back and plug it right back into the original equation. That's where I'm going to go back into our calculator, and we are going to type that into the second part of the equation. So now what I have here is I have c of t, right? Our original part of the function, c of t minus this part, integral of 4 to t of zero point 0.1 ln of x dx. So that's been plugged into here. Now I can go ahead and enable that, and we're going to graph that function, okay? And what we can also do here now is we can go to second, calculate. We're going to calculate the value. We're going to go put in 11.441, and you can see that is our maximum, okay? Now, what we also want to do is we can plug in and calculate the value of 4, and we can calculate the value of 36. Oop, 36. I think I pressed wrong. Oop, value of 36. Okay, 1.743. So as a result, by showing that, we can go ahead and show that we are at the maximum here. So here, if you go back into the functions or the scoring guideline, our first equation was setting up the prime, the derivative equaling to 0, which is the first point. We solved for t. In this situation, we used our calculator to solve for it, which is fine. And we can use it for justification. We plugged in 4, which was at 5.12. Plugged in 36, that was 1.74. Make sure you write all of this down, okay? And therefore, and here's the thing, in this one, answer with supporting work. Number of acres affected by a species is at a maximum time of 11.442. So making sure that you're explicit about your answer in these situations. I would definitely suggest that you guys go into these scoring guidelines and kind of get an idea and read up as to what other things they are or are not giving you points for. Okay. It is very easy to overlook some of these things or to understand that you can still get the right answer, but if you do not show your correct work along the way, you will start losing out on points. All right. Another thing to understand too is here, Calculus A B, at least for this 2025, about 48, 49% got above a 4 or above. Okay. Uh, Over 50% do end up passing, but there still are quite a few kids down here, whether it is that they actually don't know their calculus, or it's very possible they missed points on the algebra and the explanations. I would, take a guess that some of these twos very possibly could have passed if they had reviewed these scoring guidelines beforehand to be, sure that they are showing everything in terms of their work to get the extra points. So please remember, and especially here, and my suggestion to you is getting used to seeing these problems and understanding that the moment they say, show this setup for your calculations, that's a point. Show this setup for your calculations, that's a point. Evaluate this limit expression usually means show the limit and then evaluate. At what time is the first part, and then justifying your answer is the second part. In these situations, especially the very last problem, we tend to see it asking for 3 points on those. Okay. There you go. I mean, it took us a little bit over 10 minutes to go through all of this, but it was a lot of switching back and forth. We also have to make sure that you're able to plug in your answers into your calculator quickly. Okay, I think I cleared it right there. But as a result, being able to plug things in quickly and being able to answer them, writing them down, and moving on as quickly as possible. Okay, that is our FRQ number 1 for 2025. Showing you guys how to get a maximum score that you can on this AP test, going in with some confidence of what to do. All right, I'll see you guys in the next one.